I love the soils. I talk a lot about soil carbon as a way to, kick off a virtuous cycle of nutrient retention, soil moisture persistence, drought resilience, overall soil health, reducing erosion, and increasing crop yields. This is a nice paper that talks about enumerating soil biodiversity, and it's shocking the number that they provide here in terms of the total number of species that live in the soil. I'm recording this now for the third time. The first one I recorded fully and it had a scratchy sound in a few places, so I decided to redo it, and then this thing crashed. Now I'm redoing it and hoping that it will go well. I do this when I have free time, so I'm not being very professional in terms of the quality of the recordings, but hopefully it's not too distracting and these are useful. I do get some messages saying they are useful, so I keep doing it because I enjoy creating these contents. So what is the paper all about? It's a meta-analysis, takes all published literature. Soil is an immense habitat for diverse organisms across the tree of life, but just how many organisms live in soil is surprisingly unknown. Previous efforts to enumerate soil biodiversity consider only certain types of organisms such as animals, or report values for diverse groups without partitioning species that live in soil versus other habitats. Here we reviewed the biodiversity literature to show that soil is likely home to 59 plus minus 15% of the species on Earth. You expect to have large uncertainties in such estimates, but nonetheless 59% at the top and maybe plus 15% is a massive number. We therefore estimate an approximately 2 times greater soil biodiversity than previous estimates, and we include representatives from the simplest, so microbial, to most complex, that is mammals, as organisms. Enchytraeidii, which is like a earthworm looking thing, have the greatest percentage of species in soil, 98.6%, followed by fungi 90%, plantae at 85.5%, and Isoptera at 84.2%. Our results demonstrate that soil is the most biodiverse singular habitat. By using this estimate of soil biodiversity, we can more accurately and quantitatively advocate for soil organismal conservation and restoration as a central goal of the Anthropocene. Anthropocene is not an accepted geologic period, but people will continue to use it anyways. You may know already broadly that ocean varies very slowly, high heat capacity, so it has maybe about 15% of the total species, and land has about 85%. Even in the ocean, the bottom tends to have much higher percentage because the bottom has a lot of variability. So when you have lots of environmental variability, including physical variables like temperature, rain, humidity, etc., you get more niches for species to evolve and fit into. But now this says 59% of all species are living in the soil with some uncertainty. What's the significance in simple words? Soil organisms mediate unique functions we rely on for food, fiber, and human and planetary health. Despite the significance of soil life, we lack a quantitative estimate of soil biodiversity, making it challenging to advocate for the importance of protecting, preserving, and restoring soil life. Here we show that soil is likely home to 59% of life, including everything from microbes to mammals, making it the singular most biodiverse habitat on Earth. Our enumeration can enable stakeholders to more quantitatively advocate for soils in the face of biodiversity crisis. You are walking on soil all the time. We are building over it, we are paving over it, and we are parking over it, running over it, and we don't even know we are walking on the most biodiverse medium on the Earth. Our goal here, as they say in the end, with this effort was to provide an estimate of the proportion of life inhabiting soil, because soil organisms drive global biogeochemical cycles and human health and form the base of the agricultural food and fiber production. They are indispensable components of the biosphere. Many ecosystems across the globe are not considered in conservation efforts owing to a lack of visible organisms of interest. This inherently overlooks many soil organisms whose cryptic lifestyles are mostly incompatible with existing structures for the conservation of species. You know, you always hear about tigers, lions, exotic birds, and even reptiles that are endangered, whales, dolphins, polar bears, but soil is right there and getting constantly trampled upon and degraded by us, and we don't even know how much biodiversity there is in it. Okay, changing this requires, you know, this outlook of where to do conservation of species. This requires great attention and advocacy by the public, scientists and policy makers for soil biodiversity. We suggest that a value of 59% be used to advocate for soil biodiversity conservation and restoration as a central goal of the Anthropocene. Just some figures. I won't read all of these things, but we all seen many of these things. Earthworms are here. This is the I think this should be yeah, we'll see the figure of the Enchytraeidae in a minute. So some kind of a mites. People freak out about many of these insects, but they are doing their part in, you know, there's like a centipede or a millipede here and so on. Looking at a nice figure of the richness estimate, so lower, central and upper limits of these estimates. Mammalia, so these are share of species in soil itself in terms of percentages. So we say the Enchytraeidae, which looks something like this, but we'll see in the next figure, is 98%, and then you have global including phage. Phage is basically a virus that infects bacteria. Bacteria react wildly to them, so try to get rid of the bacteriophage by going from, you know, two sex chromosome or a diploid chromosome into a haploid chromosome, or it tries so hard that it dies. So it's like us reacting to pollen with allergies, or with to cholera by having diarrhea, and Ebola and so on and so forth, where your body fights things that it thinks are foreign bodies that need to be gotten rid of. So phage does that to bacteria. So archaea is the original form of life. Archis is the beginning in Greek. So archaea, phage, mollusca, insecta, anthropoda, protists, nematoda, arachnida, and bacteria, and so on. I won't go read all of them, but fungi we mentioned as the second largest of the species, and you know what fungi are. This is showing this in a slightly different way. Graphical overview of the share of species living in the soil. So that's 59%. So soil is the brownish color. Share of species, 59% of species live in soil. And you have Enchytraeidae, so you see here worm-like thing that I mentioned before. Fungi, Plantae, Oligoceta, bacteria, mostly in soil and mostly others. So you have nematoda, protists, anthropoda, mollusca, virus. No, viruses have this nice alien looking thing that you should go and look at microscope images of viruses. They are amazing. Look at this one. It looks like some science fiction creature, right? Archaea, they have some flagella like things. Many of these things don't move very much by themselves. It's an energy calculation. And of course mammalia, many of the rodents freak us out, but they do live in the soil and do their share for the earth system functioning. Okay, so it's a brief reading of the paper as usual, but it's still very important, so you definitely want to follow up if you want more details. And obviously it has a lot of citations of where this information was gathered from. I will leave it here, and hopefully this recording is gone well and no problems with sound and so on. Okay, see you in the next topic, which will be what will it be? Yeah, it will be about how farmers think about soil carbon as an incentive for them to do things like low tillage or regenerative agriculture, so they can sequester additional carbon into the soil. So it's a good topic as well. And then we'll look at soil moisture feedbacks to droughts and soil moisture from droughts to floods and so on and so forth. So I'll do few on soil in this series. Okay, so where am I? I should need to stop this recording and see you in the next podcast.